All right, hello everyone. This is the practice exam number 4 for Mr. Abodanza in college algebra. It has to do with logarithms and exponents and stuff like that. Determine whether or not the function is one-to-one. One-to-one function has to pass the vertical line test and the horizontal line test. So anything that's an even power, that's up, up, or down, down, will not be one-to-one. It will fail the horizontal line test. So this one is no. This one is a no. And then number 2, determine whether this one is one-to-one. Well, if you throw in a 2 and a negative 2, you'll get the same answer. So, again, this one's no. If you throw in a 1 and a negative 1, you get the same answer, so it's no. This one, x cubed, is one-to-one. X cubed looks like this, and it passes the vertical line test and the horizontal line test. Determiner, it's the same thing. So, yes, whether or not the function is one-to-one. So 4x cubed minus 8, yes, yes. Number 4. Evaluate the logarithm. So we jump right into calculator key-ins. So log base 10 of 0.0001. I could do this one without a calculator because it's base 10. I just count over how many, 1, 2, 3, 4. So it'd actually be negative 4. But you're going to want to make sure it's correct with the calculator. So you're going to hit the log base button, log base 10, right arrow, and then put in 0.000. There's 3 zeros and a 1. Hit equals, and there it is, negative 4. It kicks it out pretty quick. Log base 8. 1 over 64, so we're going to hit that button again, and we're going to put an 8 down in the bottom. We're going to put the 8 down in the bottom. Right arrow over and put 1 over 64, so you can hit the fraction bar, 1 over 64, and it'll generate the answer for you pretty quickly, negative 2. So this one, it says 4 to the x, find f of 3. 4 to the x, evaluate f of 3. So we're just going to plug that in. So we're just going to do 4 to the third. So you're going to type in 4. Oops. You're going to type in 4, hit the Xbox button, and then type in 3, and it should equal 64. 1/6 to the negative 2. So I'm going to wrap it in parentheses. So parentheses, fraction bar, 1, down arrow, 6, right arrow, close parentheses, Xbox to the negative 2. Just type it in like it looks, and it's 36. Number 8. 4 to the x, and they want you to plug in 5 halves, so it's going to be 4 to the 5 halves. So 4 Xbox, 5 over 2. This should be 32, I think. 32. Number 9, find the future value. Okay, this is a tricky one. So they want you to find the future value. So that's A print. I call that A print. So I write down A, P, R, N, T. So they give us the present value. $5,789. They give us the rate. That's the R. That's 0.05. You have to change that to a decimal. Compounded quarterly. The compounding is the N. So quarterly is 4. And the T is years, 9 years. So now I have all the information. And we're looking for the future amount. We're looking for the future value. So the parentheses goes by the P. That's one of the memory mnemonics that I use. It's going to be 1 plus a division bar to an X box. On the division bar, we put the 0.05 over 4. And in the X box, a lot of people just put the 9, but you're supposed to do 4 times 9 up there. So you put 36 up there. Now it turns into a calculator key-in. So you're going to type in that whole row. 5,789, parentheses, 1 plus fraction bar. And it's 0.05. Don't mess that up. 0.05. If you mess up with the decimal place, it's going to really wreck it. Over 4, right arrow, close parentheses, to the 36th power. And that'll tell us how much we'll have in 9 years. $9,053.67. $9,053.67. It worked out pretty well. Number 10, find the present value. So they give you the future value and they want the present value. All right? So, again, A print. Find the present value of the future value. $2,000 is the future value. We're looking for the present value. Maybe it's a typo. The rate is 0.05 again, compounded monthly. That means N equals 12 for 9 years. Find the present value of the future value. I guess that's the future value. It's really worded bad. The parentheses always goes by the P. So 1 plus division bar to an X box. So on the division bar goes to 0.05 over 12. And I don't know what 12 times 9 is, so I'm just going to put that up in my calculator, 12 times 9 up there. And here's the secret. To find the future value, to find the present value, you divide that function by the future value. So you're going to hit the fraction bar. You're going to put the $2,000 on the top. You're going to down arrow, open parentheses, 1 plus fraction bar, 0.05 over compounded monthly, 12, right arrow, close parentheses, X box. And now I'm going to put 12 times 9 up in that X box. Hit equals. So you had to invest $1,276. $1,276 9 years ago to make $2,000 at 5%. All right, the graph of the square root of x plus 4, it just goes left 4, and then we use our 1, 3, 5. And it goes up 1 over 1, up 1 over 3, so it's going to look like this. So the original graph looks like that. The other graph has to be attractive over the line y equals x. So notice, this one's attractive over y equals negative x. It's not that one. This one is not attractive at all. This one is not attractive at all. And this one's attractive over the line y equals x. So it's that choice. Number 12. So x cubed plus 2, that's going to go through 0, 2. It goes up 1 over 1. It goes down 1 over 1. This one is 1, 7, 19. It's actually 1, 7, 19. So from the turning point, 0, 2, you go up 1 over 1, down 1 over 1. And then you go up 7 over 1. But you really don't need to. You just need to know the general shape of it. And so this one's got to look attractive. Again, over y equals x. So the first one looks really attractive over y equals x. This one is two different graphs. It can't be that one. This one is two different graphs. It can't be that one. This one looks really attractive over y equals x. But notice, it went down 2. The turning point was down 2. The turning point had to go up 2. So it has to be that choice. For x cubed, the array of points is 1, 7, 19. Okay, it's a 2 to a positive x. So that means it's going to be a growth. And we're going to implement opposite same. So the opposite of the exponent is negative 2. The same as that is negative 1. So the original graph would have gone through 0, 1 and grown. This is going to go left 2, down 1. So this one is flipped upside down. This one looks like it goes down 1, but it goes right 2. This one goes down 1. I'm going to go with this choice. It looks like it went left 2, down 1. I'm going to go with that choice. If it's a log of 1/5, it's usually an upside down log. So all 4 of these meet the description. But it goes left 4. So this one went up 4. This one looks like it went left 4. It could be this one. This one went up 4. And this one looks like it went left 4. It's actually this one here. Let me see here if it went through. It's supposed to go through like this. So it's supposed to go left 1, 2, 3, 4. And the vertical asymptote went left 1, 2, 3, 4. So it's going to be this choice. Number 15. Log base 2 of x goes through 1, 0, and you go over 1. You go over 1, 2, 1, so it's going to be this choice right here. It's going to be choice A. Log is a growth, but it's a gradual growth. This is a rapid growth. This is log base 1/2, and this is negative log. 4 to the x is growth. It's going to go through 0, 1, and at 1, it's going to be 1, 2, 3, 4, so it's going to be the first choice. This is negative 4 to the x. This is 1/4 to the x. Or 4 to the negative x, they're the same. And this is another negative graph, so it can't be number 16. It can't be the negative one. It has to be a positive growth function. Okay, see how it's 1/2? That's going to be a decay function. And it's going to go through 0, 1, and it's going to decay. Because what's in the parentheses is less than 1. So this is a growth function. This is a negative function. This is a negative function. This is the decay function. If it's 1 to 1, so for 1 to 1, the x's can't repeat, they don't. And the y's don't repeat, they don't. So then you have to find its inverse. So all you do is flip-flop the 19 and 5. So it's going to be 5, 19. It's going to be negative 1, 10. And then it's going to be 7, negative 19. So it's choice B. Got to see if it's 1 to 1 first. Do the x's repeat? No. Do the y's repeat? The y's repeat. So that means it's not 1 to 1. All right, this is 1 to 1, so I have to find the inverse. I'm not going to skip any steps. I'm going to rewrite it as y equals 2x plus 3. Then I flip-flop the x and y. X equals 2y plus 3. And then I solve it for y. So I minus 3 from both sides. That's going to give me x minus 3 equals 2y. Then I divide both sides by 2. So that's going to give me x minus 3 over 2, and that's choice C. Cannot find the inverse of it because it is squared. X squared passes the vertical line test, but does not pass the horizontal line test, so it is not a 1 to 1 function. X cubed is a 1 to 1 function. So I'm going to rewrite it. I'm not going to skip any steps. I'm going to rewrite it as y equals x cubed minus 8. Flip-flop the x and y, so it's going to be x equals y cubed minus 8. Now I'm going to solve it for that y. I add 8 to both sides. X plus 8 equals y cubed. The opposite of cubing is cube root. So you have to cube root the whole thing. And that's going to give me the cube root of x plus 8. They do try to trick you. They do try to trick you. Number 23. Log base 3 of negative x. Now when the negative x is negative inside, it's going to flip it around the y-axis. So I'm going to graph log base 3 of x. That would go through 1, 0. The 3 would go through 1, 2, 3, 1, and it would grow like this. So when that's negative, it's going to flip it over on that side. And it's this choice. Log base 5 of x minus 1. That means the whole graph is going to shift right 1. This is the graph it looks like, but instead of shifting right 1, it shifted left 1. And there it is. This is the normal graph. It goes up along the y-axis, goes through 1, 0, and goes off forever. This one got shifted right 1. Asking me to solve the equation. I'm going to use the calculator. I'm going to cheat up and use the calculator on this. So what we're going to do is we're going to type this equation in exactly the way it appears using the technology. So turn it on, make sure you're in the normal mode, and I'm going to type in log 2 alpha red x. Alpha red x is down here. Close parentheses. Equals. Now you don't want to type in equals. You want to hit alpha red equals. You want to type in equals. You don't want to hit the equal sign. Equals log 5, close parentheses, plus log alpha red x minus 2, close parentheses. Don't hit equals. Don't hit equals. You want to solve it. You want to solve it. Doesn't it say solve? So we're going to hit shift solve. Now it's asking me to guess. So I have a couple of choices here to guess. First off, it cannot be negative. If I threw that negative in, that would be a domain error. So I have a choice of 10 thirds, 2 thirds, or 3. I'm going to guess 3, just to be convenient. So I'm going to push the button 3, and now I'm going to hit equals. Now I'm going to hit equals. And it sometimes takes a while for it to think about it. So the answer was not 3, otherwise it would have already got it. So it's 3.333333. So that's not 2 thirds, that's actually 10 thirds. So the calculator will solve it without you doing any work. So that's 10 thirds. We're going to do the same process for number 26. So here's what we're going to do. We're going to type in log base 9. So we're going to hit the wonderful button, the log button. Base 9, right arrow, alpha red x, minus 5, right arrow, plus, log base 9. Got to hit the wonderful button, log base 9, right arrow, alpha red x, minus 5. Alpha red equals 1. Whoop, delete. Right arrow, alpha red equals 1. Don't hit equals. Remember, we want to solve it. So I'm going to hit shift, solve. And it's asking me to guess. Now, it can't be negative 8. Negative 8 would be incorrect. It can't be negative root 26. That would be incorrect. It could be 8 or root 26. Root 26 is a little bit bigger than 5. So I'm going to guess 8. So I push the 8. Now I'm going to push the equals. And it was 8. See how quick it did when you guessed correctly? So the answer is 8.